So we're going to talk about how microscopes and telescopes work, and they're different than what we've talked to this point because we've dealt with cameras, projectors, magnifying glasses. They only involve one lens. But microscopes and telescopes have to have two lenses. So this is a picture of a microscope. You guys are familiar with it. You have a slide that you can shine light through. So you have some light, and this becomes the object. The object is the source of the light with details. Then you have what's called the objective lens. What that does is it takes the light and it focuses it at some point along this tube where it creates a real image. And then we have an eyepiece that focuses on this image and creates a virtual image that we see through the eyepiece. So what's this real image? Today, when we were looking at, or if this is future years, but we were looking at the case of the camera, and we tried to stick our eye where the screen was, or slightly after where the screen was, and it was hard to pick up anything. You couldn't really pick it up, and I think part of the reason is because your eye has a hard time focusing on something in space, whereas an eyepiece is going to fix where it focuses, and so it allows this image to be separated from the object and looking at the object instead of the image. So this is the diagram. We have somebody's eye, we have the objective lens, and the eyepiece. So you have your object, which is your slide, and remember the three things about lenses are that rays that are going parallel to the axis go through the focus. This is the focal point of the first lens, which is equally on either side of the lens. So that goes to the focal point on the other side of the lens. You can go straight through the middle and it goes straight, or you can go through the focal point on this side of the lens, and then when it hits the lens, then it goes straight. And all three of those intersect to this point. So you have an image. It's a real image because it's on the opposite side than the object. It's inverted. Now, the second lens, which is the eyepiece, has a focal length of f2. Now, what you do is you locate it so that the real image from this lens is located just inside the focal point. So this kind of acts like a magnifying glass. And normally a magnifying glass, you'd have a real object here. In this case, we have a real image. So what this does is now we treat this image as really as an object for the eyepiece, the second eyepiece. So this is kind of the object. Now, because it's inside the focal point of this second lens, then it creates this virtual image, because if we go through this point towards this glass, we go straight, it goes to the second focal point. If we go, and then it just shows three other lines, which are diverging, and that's what our eyes are able to see, are diverging lines. And if you project these back to the point of intersection of these diverging lines, they'll converge the other direction. They'll create this point. So the image that we're viewing with our eye is a virtual image, and it is larger than the original image. It's also larger than the image that is located right here. Another thing too is the image, it looks like it's this far, so our eyes are able to focus on this distance. If we try to just look here at this little thing with our eyeball really close, we just can never get it to focus. But the virtual image is at a large enough distance for our eye so that it gives us the ability to focus on it. Now, this is the example of a telescope. So telescopes make little things bigger. Microscopes make little things seem bigger. Telescopes do a similar kind of thing, but they really are, well, let me not say that. Okay. So this is interesting. I was just looking at it. So what we have is we have the object out here somewhere, way back out here at a distance. So we have these three rays coming in. We have this one, which is goes to the focal point, and then it goes straight across. This one goes to the middle of the mirror, so it goes there. This one is actually not parallel to the axis, so it doesn't go through the focal point. And this is the objective lens. So this f1 here is the same as f1 prime. Okay, so this come from the image, and they intersect here. I mean, they come from the object. They intersect here, and so we have a real image here because it's on the opposite side of the lens that the object was on. Now what we do is we have this eyepiece, and it's such that they're both located at the focal point. So instead of these rays diverging, they diverge very little. So when you look at this, it looks like you're looking at a very long distance, but the size goes from something smaller to something huge, larger. So we only see part of the field of view here. It's not like we see the whole. We look at a shrinked up version, but that smaller part is much larger to our eye. So the difference in the microscope and the telescope is, one is that in the case of telescope, the point that we want the image from the original object to be is equal to the actual focal length, where the focal length of the second lens is located. This is actually demonstrating how binoculars work. They use prisms actually to make the effective length of the binoculars longer, so this is the distance it travels, and also it inverts it so you don't see things upside down, for one thing. So here, see, it's up, right side up, then it goes upside down, and then ultimately it flips around and goes up. These are also used for reflecting. So even the prisms, they act as mirrors because the property of the prisms, the index of refraction is high enough that you get total internal reflection, so it reflects as well. If you use mirrors, you wouldn't get as an efficient transmission of the light to your eyepiece. And finally, these are some different ways of looking at reflecting telescopes. So rather than having a lens, we have a mirror. And so the light rays come in this distance, and then they are concentrated onto either a cage, which is located in the middle, so you bounce directly off of the mirror to this cage, and then you have a camera inside. The second case is where you actually bounce back off and come through the eyepiece, which is through the center of this parabolic shaped reflector. So again, a lot of times you have a camera instead of an eyepiece. And finally, in amateur situations, you have a mirror that goes in this direction instead of looking down the bottom, just because it's hard to locate yourself down here on the side. You can be standing up some more comfortable. So those are some comments about telescopes and microscopes.